Jai Hind, welcome to the course Network Analysis and Synthesis, and today I am going to discuss the loop analysis of this course. So basically there are two techniques to carry out the analysis of a network using graph theory. One is the loop analysis and the second one is the nodal analysis. The first we will discuss the loop analysis. What is loop analysis and where we apply the loop analysis. So basically loop analysis just to write the loop equations. So it is convenient to write loop equation for a network containing voltage source but no current source. Okay, if the network is containing current source, then what will do? So it is convenient to convert these current sources into their equivalent voltage sources. Why? The question is why. Though we will get answer later on. Why it is convenient to convert the current source into its equivalent voltage source? That answer will get later on. So this is the branch of a network. Branch of a network. Okay. Containing a voltage source Vs, impedance ZV, branch impedance, and having also the current source. And these are the 2 points P and Q. P and Q are the points, and this is the VB. This is the VB is the branch voltage between point P and Q. So basically we can see that we can say that EPQ is equal to VB. So VB is the branch voltage, and this branch is containing a voltage source Vs in series with impedance ZB and also having a current source. So simply we write the line equations starting with this EP. Suppose I am writing here EP. Potential of point P is EP. Then going from minus to plus, so Vs and minus I into ZB is equal to EQ. This is the line equation I have written. So EP minus EQ is equal to minus Vs plus I ZB. Okay. But what is IB? But IB is equal to IB is equal to I plus IS, so I is equal to IB minus IS. Okay. So VB is equal to minus Vs plus IB minus IB minus IS into ZB. Okay. So this much we can write. So on simplification we can get VB equal to minus Vs plus IB into ZB minus IS into ZB. Okay. This much we can write. So we can check here. So we are getting VB is equal to ZB IB minus IS. Okay. This much we can get. Okay. Now here what we will do, we just multiply with both sides with dissect matrix BF. So what will get? We get this equation. BF into VB equal to BF ZBIB minus BF ZBIS. Yes. Suppose we multiply with dissect matrix, so we can get BF BB equal to BF IB ZB minus BF IS ZB minus BS into dissect matrix. We can get. Okay. So what is this? This is basically, this is the Kirchhoff's voltage law in a loop. So relation, if we apply a Kirchhoff's voltage law in the loop, we get dissect matrix into BB is equal to 0 using KVL. If apply the KVL, we can. If you remember, while discussing the fundamental dissect matrix, we had taken a tree, then the fundamental loops, then apply the KVLs. Just to get this matrix, we apply the KVL. So VB into BB is equal to 0. So if you put VB into BB is equal to 0, the equation becomes this one. So take the, and we use also one more relation, IB is equal to dissect matrix transpose into IN. So this is basically branch current. And this is your link current. So relationship between branch current and link current. Between branch current and link current. So in place of IB we put this one. So we get this. So this is and this we get. Now look at here. It is convenient to convert current source into its equivalent voltage source, because just to get rid of this matrix. If IS is 0, then this matrix is 0. So simply we have to write this matrix and this matrix. So it is convenient to convert the current source if present in the network in its equivalent voltage source while carrying out the loop analysis, just to get rid of this matrix multiplication. Now this is VL, and VL is equal to ZL. What is this? This is the loop equation. This is your loop equation. So in carrying out the loop analysis, we have to find this VL is equal to ZL IL, and where ZL is this is the loop impedance matrix. Loop impedance matrix, which is multiplication of dissect matrix into branch impedance matrix into transpose of the dissect matrix. So where ZL is, this is ZL is the loop impedance matrix. BB is the branch voltage matrix of order B into 1. If there are 5 branches, then the dimension will be 5 into 1. IB is the branch current matrix, BS is the voltage source matrix, and IS is the current source matrix. And the dimension is how many number of branches in network has that the dimension of VS and IS depends upon the how many branches are there in the network. And ZB is the branch impedance matrix of order B into B. So it is a square matrix. Always it is a square matrix. So in loop analysis, what you have to do, we have to just find this equation and this. Sometimes they may ask to find the loop impedance matrix. Then you have to find this one. If you they are asking about the loop equations, then you have to find the VL is equal to ZL into IA. How we'll do in the network? If the network is the given, what are the steps to carry out a loop analysis? So briefly, we can summarize here. So to carry out loop analysis, these are the steps. First and foremost, you have to draw the oriented graph of a given network. Then choose a tree, because we know that the fundamental tie-set matrix is applicable to a tree. So you have to select a tree if not given in the problem. Sometimes they give, sometimes they don't give. Then you have to choose a tree. Then write the fundamental tie-set matrix, that is your BF matrix. Then determine ZB. By inspection we can write the ZB matrix. By looking into the network, we can write the ZB. Then simple multiply these three matrices, we get ZL, and this is your loop equations. So remember, if there is any current source present in the network, convert it into its equivalent voltage source, just to get rid of this matrix, multiplication of this matrix. Otherwise it will take a lot of time. And this is your loop equation. So this you have to find. So these are the theory behind the techniques, how to carry out the loop analysis. These are the 6 steps, and this is the mathematics. So now we'll take some examples to carry out the loop analysis. Suppose a problem is given. Problem. Write loop matrix. Write loop matrix equations for the network shown below. For the network shown below, using loop analysis. Using loop analysis in graph theory. Okay. If it is not written, then some may take the conventional loop analysis, graph theory. Okay. It is also given, take branch 2 as tree branch. Tree branch means twig. Tree branch means twig. So what is the network? Network is like this. This is your network. Then we have the one impedance here. Then another here. Then we have one more branch is there, and it is 1 ohm. Direction is also given, and this is branch number 1. This is 1 Henry, and also it is having mutual inductance between these two branches. And it is one mutual inductance is 0.5 Henry. Okay, this is twice Henry, and this is a branch number 3. This is the branch number 2. This is 1 volt voltage source. So this is given. It is a case of mutual inductance is present in the network. Okay. So first step is draw the oriented graph. Draw the oriented graph. Take another color. So first branch number is given and direction is also given. Direction is also given. Direction is also given. Okay, this is this one. Direction is also given. So how many nodes are there? So there are basically there are two nodes. Okay, because this is ideal voltage source. Ideal voltage source. So ideal voltage source means its impedance is 0. So we take 2 Henry and 1 volt as a single element. So draw the oriented graph. So just mark the node. This is node 1 and this is node 2. So from node 1 to 2 there is one branch. This is branch number 2. Okay. Then 1 to 2 we have another branch, and say this is your 3, branch number 3, and 1 to 2 we have another branch and direction is from 1 to 2. So these are there are 3 branches, 1, 2, 3, 2 nodes. So this is the oriented graph. Second step is take a tree. Take a tree, or it is mentioned that branch 2 as a tree branch. So take a tree. So we can write here a tree. So this is your tree. Tree contains all the nodes of the oriented graph but does not contain any loop. So, and the number of tree branches are n minus 1, where n is the number of nodes. So there are 2 nodes, so n minus 1, so there will be one branch and direction is, this is your 2. Okay, and we also know that the branches removed from the oriented graph to make a tree are called links. So how many links are there? There are 2 links. So links are shown by dotted line. This is link and this is, okay, 1 and 3. And link decides how many fundamental loops are there. So there are 2 links, so there are 2 fundamental loops. The fundamental loop contains one link and unique set of peaks. So one link means one, this is 1, this is, say this is 1, L1, and this is another L3. L3 means fundamental loop corresponding to the link 3, and L1 is the fundamental loop corresponding to the link L1. Okay, so now we have to write, then third step is write Tysset matrix. Write Tysset matrix. Why we are taking Tysset matrix? Because we have to find this one. ZL is equal to Tysset matrix ZB and Tysset matrix transpose, and VL is equal to Tysset matrix into VS. Okay, so VL is equal to ZL IL. This we have to get. So now we have to write the Tysset matrix. So here we can write. So Tysset matrix is how many rows are there in the Tysset matrix? There are 2 fundamental loops. So two rows, say L1 and L3. And how many branches? Branches, or how many columns? Columns correspond to number of branches present in the graph. So there are 3. So 3 columns. So this matrix will have 2 rows and 3 columns. L1 having the 1 and 2. So 1 is coinciding, so it is plus 1, and 2 is opposite, so minus 1, and this is 0, and 2, 3, so this is 1, and this is 1. Then we, so this matrix we have get. Similarly, we can get here B transpose 1, minus 1, 0, 0, 1, and 1. So just to get ZL, we need one matrix, that is the ZB, branch impedance matrix. So the dimension of the branch impedance matrix is 3 by 3. So we can see that there are 3 branches, so dimension of ZB will be 3 by 3. So we can write ZB. So ZB is ZB, there are 3 branches, so 3 rows and 3 columns. Okay. Dimension is B into B, 3 by 3. So this is Z11, Z12, and Z13. So we can see that. Suppose I am drawing here for your reference. You can understand. I am drawing here. Again, plus minus 1 volt. This is your 2 Henry, and this is dot here and dot here. And current is leaving here, entering and leaving. This is the direction. We can see that this is the your mutual inductance, which is half Henry. Okay, and it is of 1 ohm, and this is of 1 Henry, 2 Henry, and this. Okay, so this is branch number 1, this is your branch number 2, and this is branch number 3. So 1 means self impedance of the branch 1. So it is 1 ohm. So we can write 1 ohm. Okay, Z12 will exist if there is coupling between branch 1 and branch 2. So there is no coupling between 1 and 2, so it is 0. And Z13 is the mutual inductance or mutual impedance of this branch between 1 and 3. So there is no coupling between 1 and 3, so this element is 0. Now come to the Z21. So Z21 is the coupling between 2 and 1, so it is 0. Z22 is the self impedance of the branch 2. Remember here the units are given in the ohm and Henry. So first and foremost, you have to convert it into S domain just to make the impedance, because XL is equal to XL is J omega L. So J omega is nothing but it is SL. If you remember your Laplace transform, you have studied in your previous courses, then you must be aware of this. So 1 by SA. If the frequency is not given, it is better to convert the circuit into S domain, because this is Henry, this is the ohm. So we have to make the impedance. So we have to convert. So what is this? This is basically twice S, and this is 1S. This is impedance is 1S, and this is half S. So impedance of this 2 Henry is 2S, 1 Henry is 1S, and half Henry is half S. So this is the self impedance of branch 2. So it is S. So it is SL. So S. There is coupling between 1 and 2 and 3. So 2 and 3 coupling is half Henry. So it is S by 2. Okay. Now one more thing. Whether it will be the plus S by 2 or minus S by 2, it's depend upon the direction of the current. If the current is leaving this dot and leaving this dot, we can have the positive. If the current is entering and in the other branch it is leaving, then it will oppose. So here we can say that in the current is leaving the both the dots, so it will be the plus. Suppose in place of, suppose this is your this. Suppose dot is here and dot is here, and there is a coupling. Then in that case it will be the minus S by 2. Current is entering here and current is leaving. Current is leaving. So in this case it will be the minus. That is, this flux linkage will oppose. So this way we can complete. So this is 3 1. So no coupling between 3 1. 3 2 coupling is there. So it is S by 2. And self impedance of branch 3, which is 2S. So this way we can complete the matrix. So now ZL is equal to BF matrix, ZV matrix and BF transpose matrix. So I am just writing. Directly we can get here on multiplication we can get S plus 1 minus 3 by 2S minus 3 by 2S and 4S. Just to check whether on the multiplication of this all these three matrices we get this is. So this is your ZL. We have the Tysett matrix, multiply Tysett matrix with the branch impedance matrix, and the resulting of this is multiplied with the transpose of the Tysett matrix, and we can get the loop impedance matrix. So this is your loop impedance matrix. This is your loop impedance matrix. Now we have to find the VL is equal to ZL IL. So ZL we have get. Now we have to find the VL. VL is Tysett matrix into VS, source. So voltage source matrix. So we can write here VS is VL is equal to Tysett matrix into VS, and Tysett matrix we have just obtained here. So 1 1 minus 1 0 0 1 1, and VS dimension of VS is B into 1. Number of rows is equal to the number of branches and one column. Column will be 1. So it is dimension is B into 1. So 3 into 1. So branch we can see that there is no voltage source present in the branch 1. So it is 0. There is no voltage source present in the branch 2. So it is also 0. Now branch 3 is containing voltage source of 1 volt. Branch 3 is 1 volt. 1 volt. Now whether it will be the plus sign or minus sign. So if you remember, while carrying out the analysis, this is your ZV, this is the plus and this is the minus. This is minus, this is the plus. And the current I have taken this one. Current is entering negative terminal, leaving the plus terminal, and I have considered as the plus sign. And the numerical we can see that this is 1 volt and current is here. So here we will take 1 volt. 1 volt. 1 volt means 1. So in the matrix, in the dimension, we will write the A1. Okay. So we can, on multiplication we get real is equal to, so real is equal to, we are getting 0 0 0 0 into 1 0 0 and 0, 0 plus 0 plus 0 is 0. Now 0 plus 1 into 0 is 0 plus 1 into 1 1. So it is coming 1. So VL is this one. So the VL is equal to ZLIL. Okay. So VL is 0 1 equal to S plus 1. We have just we have find ZL, which is S plus 1 minus 3 by 2S minus 3 by 2S and 4S. Okay, into IL1 and IL3, because these are the loop currents. So we can so IL is equal to IL1 and IL3 is nothing but it is S plus 1 minus 3 by 2S minus 3 by 2S 4S inverse 0 into 1. So this way we can find the loop currents IL1 and IL3, and once we get the loop current we can find the branch current. So this is the way to carry out the loop analysis of a given network. I am giving one more example just to solve you. Size we can have one more equation. So I am just in place of this I am just removing this all the things. We can I'm just giving one more example just to just for your exercise. I'm removing all these things. For your exercise, I'm just giving one example. Just do it. The circuit is like this. This is 1 ohm. This is one. Then we have another. This is 4 Henry. This is your branch number 3. Direction of current is this, and there is the coupling between this and this, and it is M is equal to 1 Henry. This is the 2 Farad. This is the branch number 3. This is the branch number 2, and it is having the 3 Henry. This is 1 ohm. This is the branch number 1, and this. Take 2 and 4. 2 and 4 are three branches. Fix. Okay. Carry out the loop analysis. I can draw, for your reference, I can draw the graph of the network. It will be there are 3 nodes. Okay, 1, 2, and 3. This is one node. This is the node 2. This is 1, and this is 3. So this is 3, this is your 2, and this is your 4, and this is the. So for your reference, just I have drawn the oriented graph. Take a tree. So tree is this one. This is your tree. This is your node 2, 2 and 4, and these are the links 3 and 1. They are the links. Okay. So similar way we can find the loop equations using the loop analysis. So I am stopping here, and in the next class we will discuss the nodal analysis using the graph theory to solve a network. So thank you very much. Jai Hind.